So we have set the foundations now in terms of the definitions. We need the types of models, structural and functional, and we know what we're trying to do in terms of resilience, or at least trying to understand the human environment system in the lab or in a model to represent or figure out various pathways and resilience along the way, risks to reach sustainable development or be on the path to a preferred scenario, as we kept saying. So now we are ready to look at constructing human environment systems. Constructing here, of course, means doing a modeling, and nowadays there is a lot of discussion about so-called digital twins. People want to do digital twins of the global climate system, of regional systems. This is digital twins are basically computer models that replicate the entire system. What does it remind you of? Basically, we used to have so-called computer-aided design and computer-aided machines, or so CAD CAMs, where you would design everything on the computer before it was constructed. Now you have things like 3D modeling. So digital twin of the human environment system would then have all the components, so that as you keep observing what's happening in the real world, you can see what's happening in the lab as well, or in your model as well, so that in the model you can always do perturbation experiments to see where you may go into the future, but in the real world you have to only keep watching as it is evolving, and you cannot directly say where it may be headed other than based on some statistical relations of the past evolution of the system and so on. And the problem of trying to do projections based on past statistics is that it's a emergent system with too many components, nonlinear feedbacks, as we talked about, which means past relations are not always an indicator of where the system may go in the future. So keeping those kind of things in the background, here let's read what constructing human environment systems means. With systems approaches and concepts fresh in mind, it is now time to introduce some important categories of tools for constructing human environment systems in practice. Tools that have been developed for different purposes and in different disciplines, but which in one way or another could be useful in the context of risk, resilience and sustainability. These are three mantras we need to carry: risk, resilience, sustainability or sustainable development. To give you an overview of these tools, I categorize them by their focus in terms of providing structural or functional models. It's important to note that there are other ways of modeling complexity available that are not introduced in this book, such as agent-based modeling. However, using the tools provided would get you far when it comes to grasping the complexity of the human environment systems that are relevant for the purpose of this book. So I won't go into details on agent-based modeling, but there are many groups which do this at various levels. So let's say you are doing a particular human environment system, let's say just a water use or a local group of farmers sharing a water body for irrigation, then you would represent the number of farmers involved as agents. Agency is always important. You will have a representation of the physical environment of the water body with its rain and evaporation and precipitation and river runoff and human construction and everything, and you will have some kind of a game theoretical rules which represent the reality of how farmers interact with each other in the context of this irrigation water use. And you can then devise in the agent-based model how optimal rules and regulations, norms and punishments can be developed to reduce the risk and increase the resilience of the water use and keep it sustainable. Okay, so that's kind of the simple way to think about, as opposed to clubbing all humans into one box of a human environment system, in this case in functional and structural models. In agent-based models, you actually represent multiple individuals interacting with each other, so it gets into more details. There are other details of how the insights you get from these models and the agent-based models can be different, or how computationally expensive agent-based models can be. For example, if you have 500,000 people in a city or 1,000,000 people in a city and you're trying to deal with some urban problem, how do you represent the 1,000,000 people? So that comes down to, as agents, that comes down to similar choices we have to make here, as we have discussed, in terms of what components or elements of the human environment system you would pick to represent the system you're trying to model. So tools for structural models then. Explicit structural models in human environment systems can be constructed using a variety of tools that can be categorized in many different ways. For the purpose of this book, I suggest the following three main categories: Venn diagramming, which we have seen a little bit, now we'll see again, network diagramming, and mapping. The most basic form of explicit structural models in human environment systems is referred to as Venn diagrams, which we have seen before. So here it is again. So you have ellipses or circles that intersect or not. So workers union here is standing as an external box, but you have a textile mill in the context of which there is a women's association which is related to school, because the women have kids and the campus of the school may be within the premises of the textile mill and the residences that workers have, or in the same neighborhood, and the use of water and energy and everything is overlapping with the schools as well. The school has to interact with local administration for its rules and regulations and various resources in terms of, if it's a public school, there is funding coming from local administration. There may be a mosque involved which is interacting with the farmers association, because farmers may have a mix of religions. It's just an example. So think about what a Venn diagram means for any community, and it can get more or less complicated depending on what the system is that you are trying to capture. So this is named after John Venn, who was the first to conceive graphs representing all possible logical relationships between limited collections of sets of elements. So obviously limited means you cannot have a Venn diagram of the Earth system. It will get too complicated. We looked at one map of the piping diagram of the Earth system, where we have represented atmosphere as one box, ocean as one box, land as one box, humans with their activities as a separate box feeding in, and so on and so forth. So representing complicated systems graphically is always a challenge. Venn diagramming is, in other words, about conceptualizing groups of elements that share common properties and their relative relationships. Venn diagramming is commonly used in a range of disciplines spanning from pure mathematics to ecology, and is useful in several ways for addressing issues of risk, resilience, and sustainability. So we have to always keep coming back to these things that we are interested in. In addition to the utility of Venn diagrams for grasping conditional probability, which I do not address in this book, the method is also helpful to plot elements, most often agents, in a community, and their most basic relationships. So how the boxes or ellipses in the Venn diagram are interacting with each other with feedbacks and so on. So Venn diagramming is, in this context, about drawing circles that represent different elements of the human environment system and arrange them internally to symbolize their relationships, where the size of the circles signify relative importance and their position signifies how closely they are related to each other. It's important to note that for this tool to have any meaning, it must often follow for participation of people involved in the part of the world that is represented by the resulting human environment system. So now you can look at this again with the relative size of the ellipses. They are not circles, but nonetheless, Farmers Association and the Workers Union are of similar size. This one is disconnected, whereas this one is connected here, and then through there to the local administration, which has a size that is, little bit less than the mosque. School is there. So now you can see the relative role and the relative responsibilities, or let's say administrative abilities that places have. So mosque is not a administrative unit, but to the extent that farmers are getting their prayers and guidance and discussions and various other cultural norms, let's say, from the mosque, it becomes a big part of the local administration in terms of the interactions and feedbacks, because maybe the members of the local administration are also members of the mosque, or they have to very closely work with the mosque to win the elections and to manage their administrative relationships with school and indirectly to women's association and textile mill and so on. So you get the idea. The next step in terms of complexity of structural models in human environment systems is network diagramming, which spans over a wide range of tools used in various disciplines. What holds these tools together is their focus on representing the structure of some parts of the world as networks of elements, as also referred to as vertices or nodes. So then you can see how many nodes there are, how many vertices come out of these nodes, and how different nodes are connected directly or indirectly. So we'll look at a figure in a minute. And dependencies between the elements as referred to as edges, arcs, or lines. Examples of such tools include most forms of social network analysis, graph theory, and what distinguishes network diagramming from Venn diagramming is that it allows for more details in terms of the description of each element, and focuses explicitly on the dependencies between the elements. Or we talked about dependencies, which is one way, interdependencies, which is two way, and so on. Network diagramming can include both qualitative and quantitative analysis, and can involve different element variables and different types of dependencies in the same model. Although network diagramming can include geographical dependencies, as long as they are defined as relationships between the elements, the resulting model is not spatial. So you just find links and how locally or remotely elements are connected, but it is not giving you a sense of the spatial distributions of where the nodes are, how long the connectivities are, how dependency strength can be represented by thickness of the arrows, and so on and so forth. So for some of the missing things like spatial representation, we need another category of tools. So I should have a network diagram here. So let me come back and in the next podcast show a network diagram as an example. It can be seen also as a feedback diagram for the Earth system, for example. Okay, so we'll come back and do that in the next podcast.